Welcome back, learners. So now we'll move on to the next session. So where we'll be discussing about the next kind of model, which we call it as logistic regression. Fine? Yes. So what is this logistic regression? So logistic regression is, here also you have something which we call it as a response variable, and the other one is a predictor variable. Fine. Similar to the previous two models, we had discussed about linear regression and multiple regression. Here also we have the same kind. So we say response variable and predictor variable. But in case of logistic regression, so this response variable, how it will be? It will be a categorical value. So what is this categorical value? So when I say categorical value, it can be either a true or a false, or I can say it has to be 0 or 1. So your response variable should always be a categorical value. So if your response variable is going to be a categorical value, then you can't go with linear regression or multiple regression. It is always best to go for a model which will be a logistic regression. So a logistic regression, the major mandatory rule is that your response variable has to be a categorical value. That is, either it should be a true or false, or it has to be 0 or 1. The predictor variable can be of any kind of value. It can be numeric or whatever it is, fine. But only the response variable is restricted to be a categorical value. So what is this logistic regression? So as we had our linear regression and multiple regression, we had y is equal to ax plus b for linear regression. For multiple regression, we said y is equal to a plus b1 x1 plus b2 x2 and etc. Fine. Similarly, for your logistic regression, we have the mathematical formula which I say 1 divided by 1 plus e power. So we say e power, then minus a plus b1 x1 plus b2 x2 plus etc. Fine. Yes, so this is how your response variable will be calculated. So this is the relation or the formula based on which you will proceed with your logistic regression. So we need not worry about all these how it is going to calculate it, but just get to know, because we are going to just use the function for using for generating your logistic regression model. But you need to get to know the basics, so I am giving you, but all these you will be seeing in detail in your statistical analysis in mathematics, or you will also be seeing this in business mathematics. Fine. Yes. So now this y is equal to y divided by 1 plus e power minus a plus b1 x1 plus b2 x2, and it keeps going. So all these x1 x2 x3 x4 xn are going to be your predictor variables, and y is going to be your response variable. So this response variable in case of logistic regression has to be either a 0 or 1, or it can be true or false. So it has to be a categorical variable. Fine. Yes. So with this introduction, let us move on to logistic regression. So as we had seen one function in your linear regression and multiple regression, which is LM. So in logistic regression, you have a function which is GLM. So this GLM is going to be the function which will help you to develop or generate a logistic regression model. So you have here three arguments, or I say three arguments which could be passed here. So first one is the formula, as usual, similar to your linear regression and multiple regression. So you are going to use the response variable and the predictor variable combination to generate the formula. So that is your first argument. The second argument, similar to your LM function, you are going to have the data. Fine, you are going to give the data here if it is a data frame, and then finally you have the other extra one which I call it as family here. So in case of logistic regression, the family is always binomial. So this you have to have in mind. So family is always going to be binomial. So just get to know that there is one argument which is called as family, and it has to be by default binomial if you are going to go with logistic regression. Fine. Yes. So this is the syntax. So with this syntax, let us start going for developing one regression or logistic regression model and how to analyze it and when this can be used and when this cannot be used. Fine? Yes. So please follow these steps carefully so that you will get to know how we are going to go for it and when we can use this for prediction or how we can justify that this model can be used for predicting a categorical value. Fine. So in some cases, though the model could be generated, it cannot be used. We will see. Now we know this empty cars. So we had been using this in the past few sessions. So this empty cars. So now if you see in this empty cars, you can see there is one column which is AM. There is one column which is VS. You can see it is having only zeros and ones as values. Fine. So either VS or AM can only act as your response variable if you are going to plan to develop one logistic regression model. Yes, you can't use the others because these are not categorical variables. Only your AM and VS is categorical. Yes. So do you understand? So this is how you can identify which can be your response variable in case of logistic regression. Okay, so now we have identified this AM. Now I am going to take one subset of this empty cars. Fine. So for the logistic regression, so I say empty cars and I say C of, now suppose I say I am going to take cylinder, then I am going to take displacement, no, I will take just HP, then I will take weight and I will also take AM. Fine. So I am going to go for predicting, or I say my response variable is going to be AM. Okay. Now let's try printing the head of the subset underscore cars. Fine. See, you have got cylinder, HP, weight and AM. Fine. So this is going to be my input data for my logistic regression model. So now let's create the model. Now I say model underscore log is equal to. So we have seen the syntax before starting this. So I say GLM. Now I say formula is equal to. So what I do? Formula is equal to. So what can be my response variable? Obviously AM can only be my response variable. So I say AM followed by I say cylinder plus HP plus weight. Fine. So my formula part is over. So what is left out next? The data. So the data in our case is going to be subset underscore cars. Yes, and you have the other special variable here, so which is family, I say binomial. Okay, yes. So now model is created. Yes, the model is created. Now let's print this model. So let us see what the model is created, how it is created. See, you have some cylinder values, you have the intercept, you have the values, everything. But with this we cannot interpret anything. Now let me say you how to interpret. Now I say this summary of your model whichever you have created. Yes. So see, when you go for the summary, so you can see how it is printing the summary. Fine. Yes. So in the first part we have the residuals, that and all we are not worried. Now let's move on to this coefficient part. Fine. So this part. So this part is the most important one for you to interpret your model, whether it is rightly designed or not. Whether this could help you to give something which is a real valid output. Fine. When you give some response requirement or you want to go for predicting something based on some predictor variables, whether it is really fitted properly. Yes. So let us interpret this. Now you can see the cylinder HP and WT. See, you can see that there is one asterisk symbol here, and for the other two you don't have. So what does that mean? See, you can just see here the p value finally, and if the p value finally which is designed and it is generated using that GLM function or your logistic regression model, if it is going to be greater than 0.05, yes, you can see here 0.08, in this case 0.64, which is obviously greater than 0.05. When it is greater than 0.05, we say that these two variables or these two predictor values or variables do not have much impact on the response variable, that is your AM. That is not going to help you much for deciding what will be the value of AM. Fine? Yes. So in this case, only this weight is going to be having much impact for deciding your AM. So obviously in that case, this model cannot give you a better result. Fine. So we will not be using this model which is generated for predicting your AM based on these predictor variables or having the AM as your response variable. I am not going to have all these predictor variables and predict it. So it is not going to give you a good model. Fine. So this is not a good model. That is what we conclude. So this is how you can interpret the model which is developed. Okay. So generally when I go for developing a model, so whatever variables, the predictor variables used, that has to have some impact on your response variable. So this you have to have in mind. So having this mind, let us move on to a different example which will help you to still more get to know what is the interpretation of the result. Fine. Now let me go for this. Now I say df. I am going to go for reading a different one. I say df is equal to read.csv, and from this link I am going to download one file which is a data frame which is available online. Fine. You can note down this link and you can try typing in your console and check out for executing these codes. Fine. Yes. So this link, from this I am going to just download one CSV file and that I am going to use as a data frame. Fine. Yes. Now I am downloading this. See, it will take some time because from the website it is just downloading. Now I have read it and it is stored in df. Let me check what it is. Fine. So I say head of df. Now you can see you have 4 columns here. One is admit, then GRE, then GPA and rank. Yes. So all these are some scores which are there. Now I say admit. So if you see the admit here, this column is having either zeros or ones. So now if suppose I say whether I want to get to know, I want to predict whether I will get admission or not. Yes, whether I will get admission or not based on this GPA, GRE and ranking scores. Fine. Yes. So if I have to go for it, obviously admit is going to be considered as my response variable. The remaining 3 are going to be considered as predictor variable for my logistic regression model. Yes. Fine. Now let's go for generating the model. Now I say model underscore log1 because log I had already used for the previous one. Now I go for this. Now I say glm of. Yes, glm of. Now I am going to say my response variable is admit and I say my predictor variable are the remaining 3. Yes. So before going with this rank, see now I have rank here. It is saying 1, 2, 3. We are not sure how many ranks are there. So what I will do first I will convert this rank column into a factor to get to know how many levels are there. So now I say here of rank. df dollar rank is equal to as dot factor of df dollar rank. Yes, fine. So now let's see how it is printing. Now I say head of df. See, again you have the same rank. Fine, as dot factor. So what we did, we have gone for converting this integer value into a factor level. Fine. Yes. So now we have converted this rank integer into a factor level. Now let's go on for generating the model. So I say model underscore log 1 is equal to glm of. Now as I said, admit is going to be my response variable and I have GRE followed by GPA followed by my rank. Yes, fine. Now I say the data is equal to the df, then I say family equal to binomial. Fine. Yes. And sorry, I had missed this formula. So I say formula is equal to. Now my model is generated. Now let's print the summary of this model and let's check out whether it is fitted properly. Sorry, you have got error. So it is underscore log 1. Fine. Yes. So now we can see here. So you can see here. See. Fine. So this interpretation part. So this is where we had gone for printing the summary. Yes. So now with this, let us interpret the output. So what it is, and let us decide whether we can proceed or not. See, you have the GRE. So you have a star, you have GPA, you have rank 2, rank 3, rank 4. Fine, because this is a factor. We had converted it into a factor. So it is going to check out for each and every rank whether it is going to have some impact on it. Yes, fine. So now you can see what is the value here. See, this is lesser than 0.05. This is also lesser than 0.05. This is also lesser than 0.05. So all these values are lesser than 0.05. So obviously all these values, all these predictor variables are having impact on your admit. Yes. So now this model is a perfect model for you for one logistic regression. Fine. Yes. With this, now let us go for predicting. So now I say I want to predict. Now I say I want to predict based on the model, the recent model, model underscore log 1, and I am going to have a data dot frame. Yes, what are the values? Yes, so we had, let us see the values here. So it is GRE, GPA and rank. So I say GRE. Now I say GRE is going to be some value. Now I say the value is some 734. Yes, and I say GPA. So I say GPA is going to be some 8.9. Then I say my rank is equal to 3. Fine. Yes. Oh, was fitted with a factor. So the error thrown here is because we had converted the rank into a factor. Fine. Yes. Now let's make it rank is equal to as dot factor of 1. Right. Yes. And let me change here some value. Suppose I say 734 and I say here 3.9 or something to be the GPA. Fine. So now we have got some predicted value. So what is it? It says 0.80. So what does it mean? It is going to give you some percentage value for your response variable. So it says here 0.80. So what it means, 80 percentage there is a chance for that response variable admit to be 1. Yes, so this is how you can predict one response variable which is a categorical value based on your logistic regression. Okay, fine. So now if you try giving some other value, now let us see factor of 1. Now suppose I say here some 434 and this one. See, it is giving 0.12. So what does it mean? It means that there is only 12 percentage chance for the admit to be 1. Or I can say the student can get admission. What percentage? It is 12 percentage that he might get admission. Fine. Yes. So this is how you can proceed with your logistic regression model. So try working on few examples and try using some data frames or just use some built-in available CSV files and work on it. Is it clear? Yes. If you have any doubts, you can very well contact me. Thank you.